right, I've got another problem up on the board. Directions are the same as last time. We want to solve the triangle. I'm telling you that we're going to use the law of sines to find the missing sides. We're going to make sure to include the units in our answers and round to the appropriate number of significant digits. The one thing that's different here is I gave you some information. I gave you one side length and two angles, but I didn't draw a picture. So in a minute, I'm going to suggest that you pause the video and try to work this out on your own. Okay. First thing I would recommend, draw the picture. Okay, it's just kind of nice. It doesn't have to be drawn perfectly to scale or anything like that, but it's kind of nice to just have a picture to look at. Okay. Then write down the three things that you're going to need to solve for, which are going to be the one missing angle and the two missing sides. Okay. And then I would create a table like we did last time to record the number of significant digits that you have for each of these given values, so that then you know what you're rounding to for the remaining values. Okay. So go ahead and pause the video. Come back when you're ready to work through it together. Welcome back. Okay, so I'm going to draw myself a beautiful triangle. Now, I don't know that I'm drawing this to scale at all, okay? So I'm going to just label some sides. I'm going to label, this is a fairly small angle. This looks like the smallest one here, so I'm going to label that as B and that as C. It could be, because I'm just drawing this as a place to put my numbers, that I end up with things not quite to scale, so that something that's bigger than something else actually looks smaller. If I wanted to, I could adjust once I found it. I'm really just using the picture as a place to put these numbers, though. Okay. So let's see. A is the side that's opposite A, and I was given that, 2.614 centimeters. Okay. Angle B is 42.57 degrees, and side B would be opposite it. Angle C is 71.83 degrees, and side C would be opposite it. So, in order to solve this, I'm looking for angle A, side B, and side C. Those are the three things that I need to find. Let's record the numbers that we were given and the number of significant digits. It's not absolutely necessary to write this down in a table, but if you make a mistake and round to the wrong place, but you have this table and it was correct, that's going to be some partial credit. Whereas if you just round to the wrong number of significant digits and didn't show any work, there's no partial credit for that part of the problem. Okay. So the numbers I was given was 2.614 centimeters, 42.57 degrees, and 71.83 degrees. So here, that's going to be 4 significant digits. I've got 4 digits and none of them is 0, so I don't really have to think too hard when that's the case. For angles, I always do need to be careful. 2 for the degrees to the left of the decimal, 1 more for each of the places to the right, so that's going to be 3 and 4. And same thing here, 2 for the degrees to the left of the decimal, and 2 more because there are 2 additional digits to the right. So it looks like in this problem as well, we're going to be rounding to 4 significant digits when we're using that rule. Okay. All right, for finding angle A, which I think I do want to do first, because I'm going to need to know, I only know the one side, I'm going to need to know the angle that's opposite it if I'm going to use law of sines. Okay. So I know that 71.83 degrees plus 42.57 degrees plus A has to equal 180 degrees. So let's see what these two are when I add them together. Looks like together they're 114.40 degrees plus A equals 180 degrees. I'm going to plan ahead. I'm going to write that as 180.00 so that I can subtract, 114.40 from both sides. So A is going to be 10 minus 4, 6, 5. Looks like A is going to be 65.60. That would be degrees. I do want to include that 0. Remember, the rule when you're adding and subtracting is just that you round to the same place value, which in this case was the hundredths place, as the other measured quantities. The 180 degrees, that was a perfect number. These were the 2 measured angles, and they were both to the hundredths place. So my A would be 65.60 degrees. Okay, so now we're ready to go ahead and find some side lengths. So let's go ahead and just work through it in alphabetical order. So I've got one angle and the side opposite it. Now I know A is 65.60. And while I did calculate that from the others, I didn't have to do any rounding. I was able to get that. Basically, once I know these two, that one's pretty well determined. So that's just as good as a given piece of information. So I'm going to say 2.614 over sine. Oh, actually, you know what? Let's write it out with symbols first. I'm going to say A over sine A is equal to B over sine B. And then we'll plug in everything that we know. So that's 65.60 over, whoops, I'm so sorry. Side A is 2.614. I'll get that right. 2.614 over sine of angle A is sine of 65.60 degrees. I should have my degree sign there. And that's going to equal B, which I don't know, over sine of 42.57 degrees. So then I cross multiply. So 2.614 times sine of 42.57 degrees is going to equal B times sine of 65.60 degrees. Divide both sides by sine of 65.60, and so B is 2.614 times sine of 42.57 degrees over sine of 65.60 degrees. Now I know my calculator's in degree mode because I just did another problem in degrees, but make it a habit to always double check that you're in the right mode, and then we can plug this in. So 2.614, oops, turn the calculator on. 2.614 times sine of 42.57 divided by sine of 65.60, and that's going to equal 1.94177 blah blah blah. Okay. And I want to remember I was rounding here to 4 significant digits. I used some multiplication and division, so it's not to the same place value, it's to the same number of significant digits. So 1, 2, 3, that's going to be to this place. 7 is 5 or more, so I'm going to round up. So I would say 1.942 centimeters would be my units there. Okay, then we're ready to find side C. You'll notice I kept up A over sine A. I want to use the pair that involved the given side length because I just rounded to get that. This I was given, so I'm more confident that this is accurate than that this is accurate. So I'm going to set A over sine A equal to C over sine C. So that's going to be 2.614 over 65, sine of 65.60 degrees is going to equal C over sine of 71.83 degrees. We cross multiply, so 2.614 times sine of 71.83 degrees is equal to C times sine of 65.60 degrees. To solve for C, we divide by this copy of sine. So C is going to equal 2.614 sine of 71.83 degrees divided by sine of 65.60 degrees. And we pull out the calculator again. So 2.614 times sine of 71.83 degrees divided by sine of 65.60 degrees, and I'm getting 2.72724 blah blah blah. Again, I'm rounding to 4 significant digits, so 1, 2, 3, that's going to be this place right here. Since that's smaller than 5, we just drop that off, so I would say this is 2.727 centimeters. And then let's just do a quick check. It looks like that's the longest side. Good, because that's opposite the biggest angle. B was the smallest angle, and B is the smallest side. A was the medium angle and the medium side length. Good stuff.